the AI Kubernetes Show.
Welcome to the AI Kubernetes Show. I am your host, William Chia, and we are here live from the show floor at KubeCon in Atlanta, talking about how the state of AI, the changes in the world are impacting the art and science of platform engineering and software development in general. And I'm very excited to have as our guest, Marina Moore, who is a research scientist at Adera. Marina, welcome to the show.
Thank you. Thanks for having me.
I'm really excited to have you because we've chatted with a lot of folks who are platform engineers, CTOs, CEOs, these types of roles. But as a research scientist, just kind of, can you share a little bit for our audience? What is it that you do here?
Yeah, so the fun thing about what I do is I get to do a little bit of everything. And so my background is a lot in security, and I did a lot of work in supply chain security before my current role at Adera, where I do a lot more work in kind of, cloud native security in general, container isolation. I think the fun thing about where I sit is I get to look at all the different cool things happening in the ecosystem and kind of see how they fit together, look at trends, and then kind of try and push that forward and see where I can help, turn that into the next thing. So.
Yeah, this is super fascinating. Is there an example? Can you share what you're currently researching or maybe a recent project that completed?
Yeah, so a project I did really recently that's probably relevant to the AI show here is I did some work on the isolation of AI agents. And so I wanted to look at, we have these autonomous systems of AI agents running on our machines. What can we do to better isolate them? And what does that get us? Does it even work? So I kind of looked at some kind of light threat modeling of how you give agents access to stuff, how we can kind of lock that down, but still give them the power to do all that great stuff that we want them to do. And so that was pretty interesting.
This is completely fascinating, and a theme that comes up in my conversations and on the show is the idea that, new set of technologies, new set of threat surface area. How do we adapt to this? I'm really curious, is there some takeaways or some elements you can share with our audience as you dove into the research of, what kind of threat modeling you did and what outcomes you came to, or, what conclusions you came to in terms of pragmatic advice?
Yeah, totally. So what we kind of looked at is what do we want these agents to actually be able to do? And there's a lot of folks already that have been breaking down these kind of autonomous pieces of work into smaller pieces of work where different agents do different things, just for the performance, right? They work better when you give them one thing to do. They're better at that than if you give them a huge problem space and they just get confused and go off on a loop. And so if you're breaking them down anyway, how can we turn that breaking down into a security boundary? That was kind of my big idea. How can we put these different agents into a security boundary with gated pathways for data flow? So that if you know where the data is flowing, you can then secure that interaction. And so that was kind of on the security side. And then I wanted to look is this practical? So the performance side of it as well. And that part was actually, for this particular project, pretty straightforward, because the slowest part of the whole system is the tool calls to the LLM agents and to the actual inference processing. And so even if you add some layers of security on top, the performance is very, very similar. So, because that's such a big overhead already. So that made my job as a security person pretty easy.
That is completely fascinating. I'm picking up on a couple elements here. One is that, decomposing the monolith, so to speak, as we can, in Kubernetes language,
exactly.
Taking the big thing, breaking it into smaller pieces. That is not only helps you rationally think about how you want to orchestrate your agents as a human.
Yeah.
It helps you make those agents execute better because they're only doing one thing and you're not flooding their context.
Yeah, exactly.
Context
The context, exactly. That context window is key. So.
And smaller nuggets are easier to secure.
Yeah.
This is really powerful. And then this is really fascinating that you're saying that oftentimes security becomes this additional overhead.
Yeah.
We add security training to our pipelines and they balloon. But in this case, the inference processing takes so long generally today that the security overhead's small.
Yeah, and of course, there's always things we can do to optimize that overhead. But yes, I think that, in this particular context, if you look at percentage overhead, it's pretty small. So.
So I'm curious about two things. I'm curious if you see that trend continuing as AI evolves, as we, flood massive data centers with more GPUs and processing changes differently. And then, so I'd love to hear if you think this is going to kind of continue. And what are some of these elements that you think are to optimize?
Yeah, so I think that there's a couple things. So I think that what I'm hoping is that as AI grows and as the field matures, we can start thinking about how to build the security in from the start, right? We can think about how to do things right the first time. And I think as we do that, it'll become easier to optimize that, because if we're doing it from the beginning, that's what we're optimizing, is the correct way to do it, rather than saying, we have this thing that works, let's slap this on top and then try and make it a system. You know what I mean? If we do it just all at once, I think it'll actually be more efficient for everybody. So I like to see security as kind of an enabler, right? So as part of the process that really helps the whole thing work. Because I think that especially when it comes to the output of these LLMs, this kind of non-deterministic output, it's tricky for security because you want to know what's going to happen in your system. But I think it's also tricky for reliability, and because you want it to work. So I think if you can get the security piece working, you can actually improve your reliability, right? So I think this all kind of fits together in that way.
This is a recurring theme that I might call this go slow to move fast.
Exactly.
Rather than, and it can be somewhat counterintuitive, especially for those of us that spend a lot of time in the startup space, or even just software engineers in general. We want to go build something, make it work, and then figure out how to break it.
Yeah.
However, in this case, it can benefit us, and what I'm hearing from you is it can benefit us to think more rationally and broad about it and start with a secure posture.
Yeah.
That's easier than trying to bolt on the security at the end is,
Exactly.
always been a problem.
And I think if you think it through enough to get the security properties, you'll find other stuff too, right? You'll find other stuff that you want to build in from the beginning, right? And that way you can have just a well thought out system,
Is there an example that comes up either from your own workloads, your research, or your community or organization where they started with security and this is an example of how to do it? Is there a day-to-day example that comes to mind?
Yeah, so an example that comes to mind is, another thing that I do is I'm one of the co-chairs of the CNCF Tag Security. And one of the things that we do as Tag Security is we provide this assessment process, security assessment process for CNCF projects. And we've really seen that the earlier projects do these security assessments. And part of the idea of them is that you start with a self-assessment where the project themselves comes and has to think about their security posture and kind of fill out some questions about it. And the idea is rather than this being a checkbox, it's can you learn what you should be thinking and how to do this from your project? And the earlier in the process the projects do this, the easier they find it, and the more they're oh, we can fix our architecture in this way to get security to be better. And so that's been kind of a fun way to see how important it is to think about this stuff early. So
this is a fascinating take. So folks that may be watching this video that aren't familiar with Kubernetes platform engineering or the CNCF in general, there are so many open source projects that are the cottage industry around Kubernetes, support cloud native software.
Yes.
And you are at the center of trying to secure these new open source projects as they come in.
Yeah.
And so you have this bird's eye view of all of these different projects where you can be these folks kind of dragged their feet and it caused problems for them. But these folks started earlier.
Yeah. It's one of the fun things about getting to work with Tag Security and with all the CNCF projects is you get to help people succeed and see these best practices at work in real projects. So very cool.
If I'm can I get a little flavor of, if I want to think about what's on something on a security questionnaire, obviously I could go and join and run the process, but what's one of the questions on this questionnaire that would get my mind thinking in the right mindset?
Yeah, so we try to include a little bit of threat modeling in the process, which I think is probably one of the most important pieces. What are the different pieces of your system? How does data flow between the pieces of your system? Which pieces can be attacked? And I think just kind of taking that, even if you understand your system already, if you take the step back to write down all of the actors in the system, how they all interact, you can discover stuff for yourself, right? And so that's one of the cool things that we include there.
This is making a ton of sense. I love this idea of thinking and reasoning and understanding. If you think through, for example, who are all the actors in your system?
Yeah.
Whether they're agents or people or APIs or apps.
Yeah, all those things.
What are all the things that can do something? And sometimes simply the act of enumerating all of those can illuminate connections that didn't exist before.
Exactly. Even if you already knew this information, right? Just writing it down, thinking about it for a second, it can be super helpful. So it sounds kind of like simple, right? But it works.
The simple advice is sometimes the most
Yeah.
powerful. And obviously, also in the world of AI,
Yeah.
what happens is, I know immediately anybody watching the show is probably like, that's a great use case. I'll just get my agent to enumerate all the
Exactly.
actors. But then the challenge becomes, if the AI just enumerates all the actors, then I haven't done that
Then you haven't
thinking.
thought about it. Exactly. I think this is one of the challenges we have with AI, because it can make us faster at creating the outputs. And sometimes the outputs are the point, right? But sometimes the process is the point. And so I think figuring out how to use AI tooling as an enabler without us losing our brains, right? Without us losing the chance to reason and do those things that humans are so good at. So
Is there an example that comes to mind, of something that a trade-off you made recently, or either yourself or in an organization you work with, where they could have just generated this, but they chose to do it the harder way because the process was the point rather than the output? Is there an example?
yeah, I think I see this a lot with, this is a less technical example, but meeting notes, right?
Okay.
Like, I think sometimes the AI meeting notes are the right trade-off, where you just need stuff recorded for yourself in the future or for folks who missed the meeting. For our open source meetings, we do have, we have two sets of notes actually that we do. We do the notes to people in the meeting who are kind of, and that helps us, I think, keep track of what our action items are, keep ourselves on track. But then we also have the AI meeting notes, which are just like a summary of everything that happened for folks who maybe missed the meeting. But for folks who are in the meeting, I think doing it yourself is helpful, right? That's you think. So
I think is in the world of operations and site reliability engineering, we sure do love redundancy.
yes, exactly.
And so you might think, why are you taking two sets of notes? Well, they each serve a different purpose here.
Yeah, exactly. And that way, if one of them goes wrong, if someone takes bad notes one meeting, we still have the backup, right? But we get to follow that process. So
But that act of actually being active and present in the meeting to take the notes sparks a different type of mindset that when the AI is just recording and piling the notes off.
Yeah.
I think we all could stand to be in fewer meetings,
yes.
but we're all in meetings and can take this example of applying this mindset even to the way we design APIs or infrastructure or whatever it is that we're building.
Yeah. What do we need to be there for, and what can we kind of step back from? Yeah, exactly.
Sometimes the hard path is the easy path.
Yeah.
Well, I am curious, as a research scientist with that role and view of what is happening in our industry, what's your advice to, I'll give you two sets of folks, to platform engineers, those folks that are, managing Kubernetes clusters, doing the developer enablement, that part of the organization. And then what's your advice to software developers, feature developers that are, building the APIs and services and apps? As a research scientist, what would you share with those two groups to help to say, like, here's how you should be thinking about AI, or here's how you should be preparing for it?
Yeah. So for platform engineers, especially, I think the key is designing those base levels of security, right? So making sure that if you have systems that are secure by design, if you're running things in secure environments, I think it matters a little bit less if you experiment with stuff, if you try these new non-deterministic systems, find out where they're helpful. If your infrastructure starts out with like a secure baseline, I think that you can do a lot more of this experimentation without risking kind of, deleting your production database or some of these other terrible examples that we've seen when you don't have those kind of secure defaults to begin with, right? Because if you only want to give the AI permission to do stuff that you're okay with it doing. So I think just having those, and that's true of any person, any system, any identity, right? So just making sure we don't forget our fundamentals in this new world is key there. And then I think for folks using AI, I think it's cool. I think it's important to learn how powerful it is, but also what its limitations are, because there are things that it's amazing at, but I think it's important to still take ownership for like the code you're putting into the world, still take ownership for the writing you're putting into the world, right? Even if you got help from an AI system, at the end of the day, humans are still responsible for what we're putting into the world. And so how can we make sure that we use those tools, get them to help us, but still, have something valuable at the end of the day? So
I like these elements here as a platform engineering team, thinking through security first, thinking through those parameters,
Yeah.
And then as anybody doing any type of development or creation,
Mhm.
what are we putting into the world?
Yeah.
If we take the ultimate responsibility for that, all of a sudden, maybe it's not so much AI slop, it's our slop.
Yeah.
We need to take ownership for,
There you go.
our Sora videos,
Yeah.
which I've never made. But
Yeah.
well, Marina, I have certainly enjoyed having you on the show. This has been really fascinating conversation to hear a different perspective than I get to most often. For the audience, if they want to connect with you after the show or want to keep in touch with what you're doing or what Adair is doing, what the CNCF is doing, where can folks dig into that stuff and how can they keep up with you?
Yeah, so you can find me at a bunch of places. I'm on LinkedIn. I'm on the CNCF Slack, all over the tag security and compliance channels. You can find Adara at adara.dev, learn more about what we do, all the stuff we're doing with AI and with GPUs there. And I think you can find my blog post that I mentioned earlier there as well. So, yeah.
Awesome. Really enjoyed having you on the show today.
Thanks for having me. Thank you.
Created by the team at buoyant.io.